In October 2024, a colossal sunspot named AR-18664 erupted, unleashing a massive coronal mass ejection, an enormous cloud of superheated plasma, directly toward Earth. For days, this invisible tsunami raced across space, while life on Earth continued, unaware of the impending storm. The sun isn't a peaceful ball of light. It's a churning cauldron of magnetic energy. When its tangled magnetic fields snap, they can hurl billions of tons of plasma into space. If Earth is in the path, the consequences can be profound for our technology and way of life. Scientists watched anxiously as this record-breaking storm approached, knowing it could cripple satellites and power grids. The world braced for impact, a stark reminder that our life-giving star can also be a source of immense destruction. The October 2024 event was a wake-up call. Space is not empty or quiet, but a dynamic, sometimes hostile environment. As the charged particles neared, Earth's magnetic field prepared for a battle that would test the limits of our defenses. The fate of our modern world hung in the balance. Earth is protected by the magnetosphere, a vast, invisible magnetic shield generated by our planet's molten core. This shield deflects most of the sun's charged particles, allowing life to thrive and creating the auroras at the poles. Satellites, astronauts, and our technology all rely on this protective bubble. But when a powerful CME like the October 2024 storm strikes, the magnetosphere is violently compressed, exposing satellites to danger. The impact injects energy and particles into our environment, driving intense geomagnetic storms. Auroras appear far from the poles, painting the skies in places that rarely see them. During this storm, our shield was pushed to its limit, and the world was about to feel the consequences. The invisible battle in space had begun. Scientists once thought a solar storm's danger depended on its speed and magnetic orientation, but the October 2024 storm revealed a hidden threat: extreme turbulence within the CME itself. India's Aditya-L1 solar observatory, stationed at Lagrange Point 1, detected this unprecedented internal chaos, a swirling vortex inside the plasma cloud. This turbulence caused the storm's magnetic field to fluctuate wildly, destabilizing Earth's defenses in unpredictable ways. The discovery was a game-changer, showing that the internal texture of a storm matters as much as its strength. Thanks to Aditya-L1, scientists realized their models were incomplete. Turbulence must be measured to predict a storm's true impact. This breakthrough fundamentally changed our understanding of space weather. Early warning from space had never been more vital. When the turbulent storm hit, the effects were immediate. Geostationary satellites, suddenly exposed, suffered electrical faults, and some tumbled out of control. GPS and navigation systems faltered, as the ionosphere was flooded with energy, disrupting signals for aviation, shipping, and even farming. On the ground, power grids in high-latitude regions faced massive voltage fluctuations, forcing emergency shutdowns to prevent disaster. The storm was a chilling reminder of our vulnerability to the sun. Yet the skies lit up with auroras at latitudes that had never seen them before. A beautiful but ominous sign of the storm's power. These ghostly lights were evidence of our planet's shield being battered, and a warning of what could have been a far worse outcome. Our technology had survived, but just barely. The world had witnessed the sun's fury, and our own fragility. The October 2024 storm was disruptive, but also a triumph for science, especially for India's Aditya-L1 mission. Its discovery of turbulence inside the CME revolutionized space weather forecasting, giving us a new tool to protect our planet. As our reliance on technology grows, so does our vulnerability to solar storms. Early warning systems like Aditya-L1 are now essential infrastructure, as critical as earthquake sensors or tsunami buoys. Nearly everything we do depends on satellites and ground systems that are at risk from space weather. Protecting our world starts with understanding these threats, and Aditya-L1 has given us a powerful new lens. The story of the October storm is one of hope, of human ingenuity, rising to meet cosmic challenges. With every discovery, we take another step towards securing our future beneath the sun.